Huh? What is that? Quiz 2, how was it? Bad, huh? First question was, okay, no, 2 by 2 matrix. 2 by 2 matrix, I cannot give 1 by 1 matrix. It is not possible. If you can come across 1 by 1 matrix, I can actually give a problem. 2 by 2 is minimum, right? Okay. And I told obtain fundamental matrix, already done in the class, MT, right? And M inverse you have to find out. That is very easy because what you will find M0, which is a diagonal matrix or something will be like that, I don't remember. If you put M inverse, it will be very easy. So M inverse will not depend extra calculation. Multiplication of 2 by 2 is very easy, I guess. So I have given 5 marks also for this problem. So that at least people can get 7 marks. I thought 5 marks here and 2 marks, 1x, x0, x square. That is coming back. How many people do not get it? Jessica, what's happening? First problem? Cracked it. Okay. So first problem you are getting 5 marks. Okay. Then the second one. Why this arrangement is different today? I am seeing different people, different places. Jessica is coming from because we have done, but you were in the exam. Okay. So based on the exam, I think people are actually coming in front. Okay. So you didn't do well, huh? Basudha, you have not done well in the exam. Huh? Okay. The benches are actually empty here. Please come here. On the last bench, who can actually come here? This bench has to be filled up. Last benches, yeah. Okay, second question. Y cube dy dx whole square d2y dx equal to minus half. What is the assignment number of problem? This problem? Problem number 27, right? Yeah, so I told actually I will be giving problem to the second page. I gave problem from second page only, correct? No? Yeah. What was the problem then? Only thing is that this problem I wanted you to do these 3 steps. First step was order reduction, right? Because this problem was non-linear ODE, so you have to reduce the order. Only one step I gave 1 mark. Next step was equidimensionality or scaling. What was your conclusion? Scaling part? Huh? What is that? Is it equidimensional in X or equidimensional in Y? Pardon? Scaling value, what is that? What do you substitute? P equals to? Minus half. See, so many people did it. That means you have done very well in the exam. And then after the solution from you, I didn't want. I told you get somehow dy dx also fine. If you get dy dx, I will give 2 marks. How many of you got dy dx? Only 1, 2, 3. Okay, 4. See, only dy dx I wanted. Not even solution because I knew that in the hurry you may not be able to find again another integration. So we have to finish at dy dx. That's why I decided, right? If you want to find solution, you can do that. No problem. Anyway, I will give you the 2 marks. So these 7 marks, Jessica, you cannot get 7, right? But it should be done properly, no? Did you get the final solution? But did you do the equidimensionality part? See, point is, the second problem, it can be solved in another way also, right? Basudha did in the assignment. Direct method, if you do, what will happen? How many people do you give direct method without doing the second step? Any hand, please? So, how much marks do you expect for that? You tell me, I give the marks. Who did the direct method? You tell me. Pardon? Yes, tell me now. I am not able to hear. See, 1 plus 3 plus 3 was there. So that means order reduction you have to do, even if you do direct method. So 1 marks is given. So you are bypassing the second method means 3 marks is not there. So you will be getting 4 out of 7. Is that okay? 1 plus 3 equals to 4. Okay, it is 1 plus 3 plus 3. Solution from I wanted means you got the solution from. I should give you 3 marks there. Then I cannot do anything. In between the equidimensionality part, if you don't do, 3 marks will not be given. Right? The people who have done direct method. Initially I thought I would give 0 or 1, but I thought that I should not do so much of this thing. But how many of you guys did direct method? Only 1, 2, 3. Okay, so you guys will get 4 out of 7, okay? But if you do direct method, nothing is there the problem. I am just giving for the mercy. Nothing is there, right? Basudha? Direct method until you compare now. Direct method is very easy, right? Yes. Okay. Third question. Obtain the orthonormal basis sets for the basis 1x x square. That you should not compare. I told yesterday this problem I am giving, that way I get the 0, 1 domain. What you could have done, you could have written down in your one page handout and could have copied from there. I allowed that copy also. 2 marks. How many of you didn't get it? So that means all of you are getting 2 marks at least. Okay, all of you. I mean Amit also. Okay, Amit is doing good. Yes. Congratulations to Amit. You are doing really good. You got it. Obtain the expression for fx equals to 1 by x square plus 1 using the orthonormal basis functions. Okay, how do you do it? This I explain. Summation ci phi I. Then next integral
fx into
e1x, then you get c1. Divided by that one, yeah, divide by don't need because it's orthonormal function already. If it is orthonormal, you don't have to divide by. And third question, that means 2 plus 4, 6 marks given. Another 2 marks is very important. What is that? Fx at x equals to 0.25 based on the above expression on your calculator. You found some difference, right? How much a difference? Huh? Okay. How who solved it? This is just putting the value only. Putting the value. There is some accuracy problem. How do you improve the accuracy? That's the last question. How to improve the accuracy? I will give you another example. You remember that expansion? What is that? Expansion 1 plus? Minus or plus? So on, right? It is this kind of thing. It is 1 by x square root to the power minus 1. So what actually happens? I took up to x square term, orthonormal function. That means accuracy can be improved if I add simply one more term. That was the answer. Simple question. If I add one more term in orthonormal function, so I did 1x x square. If I take x cube and take orthonormal say e3x, if I add data, definitely I get better approximation. That's what I wanted. 2 marks was given. Okay, now what is your complaint here in the question? I mean, yeah, no, and no means what? Then what you should be getting 20 marks? No, then there should be something wrong. Where it went wrong? Because I have given assignment long back. The big assignment I gave one problem from there. Okay? Whatever procedure I give in the class, I ask same procedure. Then that is there. Number 1 is e to the power t I have done already. Number 3 is very simple. You can see. So which question was better? So first quiz or second quiz? Second quiz was better. What's about you this side? Which was better? Second quiz better. That means the last quiz average was 5 in the mathematics and thermodynamics average is 4.5. Highest of thermodynamics 8.5. Highest of mathematics is 17. But average of both the course almost same. Okay. So but that does not mean I can give you guarantee thermodynamics question is easier than first quiz. Okay. So that I don't know, but we'll see that how the only thing is I can admit your comment. This question is easier if I see the average is better than first quiz. Average was 5 only. Okay. So we'll see that what we are. So we are doing the we have done d2 by dx square the operator where we have done the eigenfunctions and eigenvalues. Eigenvalues cannot be negative, it could be 0 or positive, and we have seen provided that 0 eigenvalue should give the non-zero eigenfunction because eigenfunction cannot be trivial. Eigenfunctions cannot be trivial, right? So the d2 by dx square, the case we have seen eigenvalues pi square, 2 square, pi square, 3 square, pi square, and so on. And eigenfunctions are sin pi x, sin 2 pi x, sin 3 pi x, and so on. Now next I will be giving another problem. d2 by dx square minus du dx plus lambda u equals to 0. You can see this is the eigenvalue problem, and of course you need to have the boundary condition, and of course it says that minus lambda u. So this is a complete eigenvalue problem, but Wx equals to 1. It says Wx equals to 1. But this is a self-adjoint operator, non-self-adjoint operator. Is this a self-adjoint operator? You have seen it. We have seen this kind of operator earlier. If n equals to du equals to du by dx square minus du dx, L star was du by dx square plus du dx. Right? We have seen it. That means this operator is non-self. This operator in this case we cannot say non-self-adjoint, but here definitely we can say L is not equals to L star. Maybe B equals to B star, but since L equals to L not equals to L star, we cannot have the self-adjoint here. However, based on the Sturm-Liouville problem, we can have the operator as self-adjoint. Okay? So in that case, we need to find out Px, Qx and Wx. Okay? What is Px here? What is Qx here? And what is Wx here? That means this I will be converting to ddx of Px du dx plus Qxu equals to minus lambda Wxu, which is called as Sturm-Liouville problem. In that case, any operator can be converted to the self-adjoint operator. In that case, any operator can be converted to the self-adjoint operator. So in that case, so if the original operator L is not equals to L star, but we could see that if we can write this entire thing as ddx of Px du dx plus Qxu equals to minus lambda Wxu, in that case the entire problem will be converted to the L equals to L star kind of problem, and of course if B equals to B star, then you can say the operator is self-adjoint operator. So in that case we need to find out the Px. What is Px? Is it on? Qx equals to Wx equals to 0. Somebody is saying 0. It is multiple power. Why? Because it is Px, Apx by A0x. I am giving the steps because some people are actually having confusion. Right? Apx equals to 1. A0x equals to 1. Px equals to e to the power minus x. So this is e to the power minus x. What are A3, A0? You please refer to the original differential operator. How I express. You please refer to my previous class note where I expressed A3, A0 everything. So because this kind of thing you can write in terms of A0 du by dx square plus A1 du dx plus A2 u equals to minus lambda A3x into u. With that, if you compare, you got this one. I think you might have forgotten. But if you remember that, this is the expression. Okay, so this entire thing can be written as ddx of e to the power minus x du dx plus Qx equals to 0, then equals to minus lambda e to the power minus x u. Am I correct? Am I correct? Yes or no? Yes. Okay. So this is the situation now. The situation we have, right? So what are you getting then? From here, you get e to the power minus x d to u by dx square minus du dx plus lambda u equals to 0. Am I correct? So now you can see that earlier we had only this one. If you multiply by e to the power minus x with this, it's a magic. This entire thing will become self-adjoint. Okay? That means what will show you that the eigenfunction for this kind of operator will be orthogonal with respect to weighting function. Why? Because Wx is not 1 here. Wx is e to the power minus x. Right? If you look at original problem of the self-adjoint operator, we have done in the last class. Please go back to the last class note where we have solved this eigenvalue problem. You remember, right? Dx of Px du dx plus qx equals minus lambda wx. What is the orthogonality criteria for the eigenfunctions? Can you tell me the eigenfunction orthogonality criteria? Can you please tell me the orthogonality eigenfunction criteria? What I cannot hear you. Can you please come here? You should not be sitting there because you are interacting maximum in the class. Come here, space is there. If you want to learn something here, please come to the forward. Otherwise your classmates will not interact much. Desika. Yeah, what is the eigenfunction condition here? Yes, I'm sorry. Yes, Desika. If it is that situation, what are the orthogonality criteria for the eigenfunction? Eigenvalues are real. Eigenvalues are real. They are non-negative. All those things are there. Eigenfunctions, or if there are two eigenfunctions, unx and umx, what is the orthogonality criteria? Inner product, unx, umx, weighted inner product. That means it says that integral a to b wx unx umx dx equals to 0. That means unx umx they are orthogonal with respect to the weighting function. That means unx umx are orthogonal with respect to weighting function. For d2 by dx square operator, we found that wx equals to 1. That's all. We could say integral 0 to 1 unx umx dx equals to 0. But it is not necessary for this case. If the wx is not 1, that means when wx cannot be 1, when the operator is non-self-adjoint. In that case, you make the operator self-adjoint, but wx will be non-unity. It will be having some value. So in that case, what actually happens? It is possible to find out the eigenfunction. How to find the eigenfunction? To solve it. How to solve it? d2u by dx square minus du dx plus lambda u equals to 0. And how to solve? Trial solution. What is that? E to the power mx is the trial solution. If you have the trial solution, what is the auxiliary equation? What is the auxiliary equation? I am teaching something in the 10 plus 2 mathematics level here. What is that? M square minus n plus lambda m, lambda equal to not lambda n, lambda equals to 0, right? So in that case, what will you get? M equals to minus 1 or plus 1? Plus 1 plus minus 1 minus 4 lambda. Now the thing is that we have proved it for the generalized case that lambda is what? Lambda is non-negative. Lambda is either positive or 0. But we have to see whether lambda can be 0 here also. So I will now do some experiment mathematically here. First is lambda equals to 0. Sorry, lambda less than 0. I will take lambda equals to I will take, and lambda greater than 0 I will take, and I will see how my eigenfunctions would behave. First case, lambda less than 0. Okay? If someone does not want to prove that lambda is greater than or equal to 0. So case 1, if lambda less than 0, what actually happens? M square minus m. Lambda is less than 0 means we can substitute lambda by minus mu square equals to 0. Mu square is always positive. Mu is some real number. Okay? Real number 2p minus 3. Doesn't matter. If you take 2 the square, it will be positive. So it is nothing but m square minus a minus mu square equal to 0. What is m then? 1 plus minus 1 plus 4 mu square by 2. Okay? What is my solution? A e to the power m1x, here m1 is 1 plus the square root of 1 plus 4 mu square by 2. m2 is 1 minus the square root of 1 plus 4 mu square by 2. So it is e to the power m1x plus b b into x. Now incorporate the boundary condition. U at x equals to 0. What actually happens? A plus b equals to 0. Both are homogeneous boundary condition. U at 1, ux equals to 1. What actually happens? X equals to 1. What actually happens? A e to the power m1, b e to the power m2 equals to 0. How to get a and b? By Cramer's rule, right? So you can use Cramer's rule to find out a and b. What is a then? How to find out? By determinant is what? E to the power m1, e to the power m2, and here a will be replaced by 0, 0, 1 e to the power m2. Am I correct? Cramer's rule wise? Yes or no? And you can see both a and b are becoming 0. That means lambda equals to 0 cannot be a candidate for the eigenvalue because eigenfunction is coming 0. This is a very low level thinking, but I feel that this kindergarten level of thinking is required to find out the eigenvalues or to visualize the eigenvalues. Next we will be talking about lambda is, what is that? Any questions? Lambda equals to 0, right? If lambda equals to 0, what actually happens? So first we found lambda cannot be negative. Now lambda equals to 0 can be, is it possible? So it is m square minus n equals to 0. So m into m minus 1 equals to 0. M is 0 or 1. So your solution is u equals to a e to the power x plus b. Am I correct? E to the power 0 equals to 1. E to the power 0 into x. So u0 is nothing but a plus b equals to 0, and u1 a e plus b equals to 0. Am I correct? Apply the Cramer's rule. A equals to what? Determinant. Here it will be denominator will be what? 1 e 1, right? Here it is 0 0 1 1. Again here becoming 0. That means lambda is equal to 0 cannot be the candidate for the eigenvalue for this problem because eigenfunctions will become 0, which is not possible. So only case remaining is lambda greater than 0. So let's look at the lambda greater than 0 condition. Okay. Next we will be going for lambda greater than 0. That means lambda I am assuming is plus mu square. Okay. If you assume lambda equal to plus mu square, what's our equation? M square minus m plus lambda equal to 0, which will give m square minus m plus mu square equals to 0. So m equals to 1 plus minus square root of, please fast 1 minus 4 mu square by 2. Okay. So what is my solution then? My m1 and m2 is there. A e to the power m1x plus b e to the power m2x. So you can write this as a e to the power x by 2 e to the power 1 minus 4 mu square x, sorry, by 2 plus b e to the power x by 2 e to the power minus 1 minus 4 mu square by 2 into x. Am I correct? Now the thing is that the mu value, what will the value of mu? The matter is not over here. Any value of mu, this is not possible. Any value of mu is possible. The question is there. Is there for any value of mu is possible? Yes or no? Okay, so we'll take the two regimes of the value. First we will take mu less than half. one case. Second, we think mu greater than half. So half is the boundary. For any real numbers, we can have set of real numbers less than half. We can have set of real numbers greater than half. If you take less than half, what actually happens? If mu less than half, what actually happen? u0 equals to a plus b equals to 0. Remember that mu is less than half. That means these guys will always positive. These guys will always positive, right? So u1 will be a e to the power half e to the power 1 minus 4 mu square by 2 plus b e to the power half e to the power 1 minus 4 mu square by 2 equals to 0. Am I correct? This because the equations will remain intact. Because if mu is less than half, that means this is always the same. The sign will not change. If mu is negative, the sign will change. Okay? And then all the magic will start. If you want to solve this by Cramer's rule, what will happen? A and B will be how much? A and B will be how much? Cramer's rule. Just now I have done it. 0, 0 only. Yes. So mu less than half cannot be the eigenvalue. Because again you are getting eigenfunctions. Okay. So now we can see that so many conditions. So if things are given, if you want to have the pinpoint, you have to do so much of the case studies. Otherwise you won't get it. What is the exact boundary or limit of the eigenvalue? Next question only. Next part is remaining, which is mu greater than half. Only part remaining, and it has to be the eigenvalue. Let's see that part. Ux, which is a e to the power x by 2 e to the power. What will happen if mu is greater than half? That means we have the less than some negative value will be coming under the square root. So, and we know that I equals to. So if you substitute, what will you get? E to the power I into square root of 4 mu square minus 1 by 2 into x, a b to the power x by 2 e to the power minus 4 mu square minus 1 by 2 into x. Okay, e to the power ix. So you know the De Morgan's theorem, e to the power I theta, which is cos theta plus I sin theta. So it is e to the power I theta cos of 4 mu square, the square root of 4 mu square minus 1 by 2 into x plus I into sine of square root of 4 mu square minus 1 by 2 into x. So what did you get? What did you get? The u of x compact form. E to the power x by 2 a cos alpha x plus I sin alpha x plus b cos alpha x minus I sin alpha x, where alpha is the square root of 4 mu square minus 1 by 2. Do you agree or not? Yes or no? Agreed. So what you got finally? E to the power x by 2 a prime cos alpha x plus b prime sin alpha x. A prime is the entire this thing. A plus b is the a prime, right? B prime is what? IA minus IB, right? Is B prime. That's it. My job is done. Very compact. This is the way actually we always do that. Even this kind of thing you have done in 10 plus 2, but you don't remember the derivation. Okay. This is my eigenfunction. Now, if you want to have the quantification, they need to prove the boundary condition. What is the boundary condition? U0. What is U0? If you put, what actually happens? A prime will remain this prime, this will go because cos sine of 0 is 0. So we have A prime equals to 0, right? Am I correct? U1 will be what? E to the power half A prime is 0, so B prime sine of alpha equals to 0, which is sine of n pi. Am I correct? Last time we have done similar kind of thing. B prime and e to the power half cannot be 0. These are not constants, cannot be 0. So sine of alpha equals to 0, which is sine n pi. I should not say here, I actually come to here directly, which is actually exactly sine alpha equal to 0, and then alpha is nothing but n pi. Then what is the eigenvalue? Alpha is not the eigenvalue. What is the eigenvalue? Lambda is the eigenvalue. Lambda is what? Lambda is mu square, correct? What is mu then? Alpha is n pi, means the square root of 4 mu square minus 1 by 2 equals to n pi. That means what? 4 mu square minus 1 is nothing but 2 square n square pi square. Am I correct? Yes or no? Yes? What is mu square then? Which is lambda. What is mu square then? What is that? Mu square means? What is 1 by 4 plus n square pi square? Simple. Okay? 1 by 4 n square pi square. What are the values of n then? Can n be 0? Can n be 0? If n equal to 0, what is actually happening? Lambda equals to? That means, so you can see that when I put mu greater than, less than half and greater than half, I was missing one value. Mu equals to half. And the eigen function cannot be discontinuous. Some value will be there all the time, either 0 or some value. So mu equals to half would be having one eigenvalues, and this is the classic example. For n equals to 0, we have the value which is 1 by 4. Okay. So if n equals to 0, what actually happens finally? If n equal to 0, so alpha is still, alpha is still non-zero. Am I correct or not? If n equals to 0, what is alpha value? Alpha is how much? Alpha is 0. That means, then again the question is, yes, that's what I think. Here is the catch again. I put a question mark. You tell me which is the eigenvalue then. Mu less than half, mu greater than half, mu equals to half. Which is having the possibility? We have seen no. This is possible. Is this possible? Because we have to get the non-zero eigenfunction. Are you getting non-zero eigenfunction here? Okay. So that means this is coming as impossible case. Mu less than equals to half. So mu equals to half is the only possibility based on. Please write down this very important point. Why often you do mistake? Based on non-zero eigenfunction. Is not possible based on zero eigenfunction. Okay? So we found the value of the eigenvalue, which is lambda, which is 1 by 4 plus n square pi square, where n equals to 1 to infinity, not 0. 1 to infinity. So 0 or 1 we decide based on the eigenfunction. Sometimes, quite very rare case, you will see that for n equals to 0, eigenfunction is actually having non-zero value. What is the case? I will tell you. If you see some derivative boundary condition, if I would have had u prime 1 equal to 0, in that case quite often you will see even for n equal to 0, eigenfunction is non-zero. So whenever you put n equals to 0, be careful. Just see you are getting eigenfunction 0 or not. If eigenfunction is becoming non-zero, then in that case n equals to 0 will give the one of the eigenvalues. So our rule is that eigenvalues are non-negative. Does not mean it cannot accept 0. It can accept 0, but it cannot accept also based on the 0 eigenfunction. Okay, so what is the next part? Now, how to find the eigenfunction? What is the eigenfunction then? u n x equals to e to the power x by 2, a prime is 0, b prime will be substituted by bn sine of 1 by 4 n square pi square, sorry, alpha is how much? N pi. Am I correct? Eigenfunction, did I write correctly? U and x is nothing but e to the power x by 2, a prime we found 0, b prime will be replaced by bn prime, sin alpha x will be replaced by alpha is n pi x. Why it is bn prime? Because n can be 1, n can be 2, n can be 3. Based on that, these values of bn prime will change. We cannot say that the same all the time. Bn prime will be same. Bn prime may be different. Okay? So this constant can be different. So in that case, what actually happened? This is your eigenfunction. How to verify orthogonality categories? What will happen? U n x w integral 0 to 1. U n x is what? E to the power x by 2 bn prime sin n pi x. Next, u m x will be what? You tell me here. U m x, I wrote u n x. E to the power x by 2 bn prime sin m pi x. What is the weighting factor? E to the power minus x dx. Now you see e to the power x by 2, e to the power x by 2, e to the power minus x, they are becoming 1, and that's what we are having. Orthogonality criteria 0 to 1 sin n pi x sin m pi x dx, which is 0 if n equals to n not equals to m. 0 if n not equals to m, and non-zero not equals to 0 if n equals to m, because they are orthogonal functions. Fun clear? Yes or no? Can you verify first statement? Can you verify if n is not equals to m, it is 0? Why you accept what I said? We have to verify now. Can you do the integration and tell me whether why it is 0? Why it is 0? Sin n pi x sin m pi x 0 to 1 dx. Orthogonal function, you know that. We have seen the orthogonal vectors. If the two vectors are not the same, e1 dot e2 equals to 0, e1 dot e3 equals to 0, but e1 dot e1 is 1 0. Similarly, here en and em, they are dotted. Okay, so why they are 0? Why they are 0? Why they are 0? Any idea? How to find out? It's a 10 plus 2 integral. We have done in 10 plus 2. How to start this integral? Evaluation of the integral. Jessica? Not sine of a plus b, it is half 0 to 1, 2 sine n pi x. I am seeing that your mathematics fundamental is so bad. And then you can write this as the sine 2 sine a sine b is cos. What is that cos? What is that cos then? What is that final form? N plus m pi x. And then minus or plus? What is cos a plus b? Cos a cos b minus n. Is it plus n here? What is cos a minus b? What is the final form then? Is it correct? Of course not. You are having cos a cos b minus sin a sin b. This sin a sin b is there. How can it be plus here? What is that answer? Tell me. Minus cos of what? What is that? Minus will not be there. First I want the plus. Not n minus n. N minus n pi x minus cos n plus m pi x dx. You tell me the answer finally. What you are getting? I want only this integration. What's the answer then? How to then evaluate? Integral cos x dx is what? What is that? First is sine of m minus n pi x by m minus n. Second term will be sine of n plus n pi x by m plus n. If you put the limit, what are you getting? If you put the limit, what are you getting? You can see that sine pi, if whatever is there, is 0 only. Okay, so both the limits will give 0. So finally, you will get 0 here, and that's what it shows. These eigenfunctions are orthogonal, right? Okay, so we have done the enough exercise on the eigenfunctions, and we have seen many cases. I have discussed the generalized format of the operator. We have taken different self-adjoint operator. We have taken non-self-adjoint operator. By Sturm-Liouville theory, we made the non-self-adjoint to self-adjoint. Then we took the two examples. One is d2 by dx square, where we found very easily eigenvalues, eigenfunctions, because operator itself is self-adjoint. Next we took the operator d2 by dx square minus ddx, which is non-self-adjoint operator. By Sturm-Liouville theory, we made it self-adjoint, and in that case, we found the eigenvalues, and we have tested three extreme cases. That means if a complicated operator is given, we have to do all possible extreme cases to find the eigenvalues. What are the cases? Lambda equals to 0, lambda less than 0, lambda greater than 0. With that, we found the proper eigenvalues. Then we found the eigenfunctions, and we have also found the orthogonality criteria based on the weighting function. Now we'll be doing the solution without solution. That means we have done in Ax equals to b. You remember that I used to tell how to solve Ax equals to b without solving, right? How did we do that? We do the same thing for this functional space. So whatever we have done in the vector space, I am exactly repeating for the functional space. Ax equals to b. How to solve? Without solving. Do you remember? So x vector can be expressed a linear combination of basis functions, which is alpha I, ui. Ui are the eigenvectors. Okay, eigenvectors are the good basis vectors, and if matrix A is symmetric and functional space, you are lucky. We don't think about the non-symmetric matrix because any operator can be a self-adjoint operator. Wonderful. So you should not worry about bi-orthogonality criteria here. Here everything is orthogonal. We don't have any bi-orthogonality criteria because vector space is very complicated, I feel, because vector space we cannot have this automatic self-adjoint. There are procedures to make it self-adjoint, but in functional space with the Sturm-Liouville theory, we can always have the self-adjoint operator. So I am assuming that matrix A is symmetric or self-adjoint. In that case, what actually happens? We write summation I equals to 1 to n alpha I ui equals to b, right? Remember that not solving summation I equals to 1 to n alpha I a ui equals to b. And since ui are the eigenvectors, we know that it is nothing but lambda I ui, right? So what you do right then? Summation I equals to 1 to n alpha I lambda I ui equals to b. How to find out alpha I? Then eigenvectors will be, since matrix is symmetric, eigenvectors will be always orthogonal. We have learned that. So if you take inner product with respect to ui, you get alpha is nothing but inner product bui divided by lambda I ui because they are not orthonormal eigenvectors, they are orthogonal eigenvectors. Okay? With this we found the solution without solving. The same thing is impossible for functional space. Let's look at a couple of problems and we'll see that without solving, that means with the help of eigenfunctions, we can get the solution for the differential operator. So let's take up. So this type of what are the things I am covering now? These are not there in the textbook, so please follow the class notes, which is self-sufficient. So d2u by dx square equals to 1, ux equals to 0 equals to 0, ux equals to 1 equals to 0. Real part is not eigenvalue problem. The simple differential equation I want to solve by without solving. That means using eigenfunction. I want to solve with eigenfunction. I want to solve this with eigenfunction exactly for the same procedure. And exactly for the same. So what is the procedure first? What should I write? I have the procedure here. Same procedure I want to extend here for to solve this problem. How to start? What's the first step? Amit? I cannot get any answer from you. Jessica? Yes, what doubt?
Sir, even if B is not equal to B star, then also I can convert a function, a non-self-adjoint function to self-adjoint. Even if B is not equal to B star.
For these kind of things, B equals to B star.
Yes, sir, but suppose B is not equal to B star, then
if B is not equal to B star, it is definitely not. Definitely not. We are not talking about that part. We are talking about L equals to S star. B has to be. See, basically what actually happens that we already discussed this part. JU has to be 0. If it is not 0, there is no question to have eigenvalue problem. If it is 0, B equals to B star, L equals to L star, then only you can get the situation. For our heat transfer and mass transfer problem, generally speaking, the kind of boundary conditions we apply always gives the eigenvalue problem. Okay? Good question. Okay. Yes, Jessica. No, I don't want any explanation. I want the first step. I want the first step. You understood this one? Okay. What is the operator here? Here operator is A, right? What is the operator here? d2 by dx square. What is the eigenvalue problem for this operator? What is that? d2? Not d2, u is a variable. How do I write eigen functions in the functional space? I have my own notation, no? I have my own notation. I don't write u. Eigenfunction notation was the just now I have done the notation. I have finished. Just now, 2 minutes back. d2 what? D2 he told no. Do you think it's a fool? He's not a fool. He told just now. Don't talk nonsense, please. He told just now. Don't waste your time. If you don't know, just keep quiet. Don't act smart. What's the typical notation? Vasudha. Just now I did the notation. Just 1 minute back, maybe. It is there in your notes. See, Ax equals to B. Eigenvector is not X. Eigenvector is Ui bar. Similarly, U is the variable. What is the eigenfunction? Un. Yes, Un. Equals to what should I write? Minus lambda. Why not W? X. Wx is because Wx is 1. Why? Because it's self-adjoint operator by nature. So if you can calculate that, the Px, Qx and Ws, definitely Ws will be 1. Even if you can write Ws here, Ws will come as 1. Okay? For this case, we have already derived it. Then, for this thing, this is not complete. We need to have boundary condition. The boundary condition can be obtained from the homogeneous situation of the problem. Homogeneous situation is un x equals to 0, un x equals to 1 equals to 0. This will give the complete eigenvalue problem. Slight complication. We don't need boundary condition here, but we need boundary condition for the functional space. We don't need boundary condition here for the matrices. Very easy. Here it is the boundary condition. What are the boundary conditions? It is given here. How can I write? Because any function can be expressed as a linear combination of basis functions. My basis functions are eigenfunctions. If each eigenfunction is equal to 0, then if you